Hey guys, so now that we have developed a prototype of the app, we're going to polish or improve the prototype that we have, right? There are three sections. So the first section, we are going to work on the shape of the tables. So we are going to highlight the first five rows, and then we're going to make the width equal, okay? And then we are going to make the plot so that the user can switch back and forth between count plot and rate plot. And we're going to add one more row at the bottom of the app for narratives. All right. So let's start on, um, let's dive into improving the tables. Okay. So if we were to look at the textbook, it's a section 4.5 polished tables. All right. All right. So let me delete all the other tabs here. Let's start building on 4.4. So let's save this as section 4.5. And what we need to work on, so I mean, let's run this app from section 4.4. Looks like this, right? So it has a different length, right? And you can see the space between the tables, they're not equal. Um, so those are the two things that we'll improve on, right? So we want to make the, the height and width equal across three tables, right? So that they're more aesthetically pleasing. Okay, so let's stop. So the first thing we need to do, so let's work on the height, right? So let's limit it. Let's just uh, work on the code to display the top five rows or top five categories, right? So which means we need to work on here, this code here. There are many different ways to do it. But the author um, used the forecast package. So let's add. So display top five rows. So which means we need to work on this location variable, and he uses lump factor lump function is a way to collapse rare levels or rare categories into one big bucket, right? So location, right? And then we pass this to the count function. Oh, by the way, we need to specify how many, say five. Okay. So let's add this to all the other tables here. So we can add this to all the other tables. Oops. Indentation is incorrect, which means I did something wrong. Why do I? Okay. So note that there are axes here. So let me undo to trace back the error I made. So Control Z to undo, Control Z, Control Z. Okay. So now all the axes gone. Um, okay. So I'm gonna hit Tab. I selected N, um, and then I entered 5. All right. I'm not seeing any X's. All right. And then I copy that, and then I pasted here. All right, no X's so far. Good. And when I hit return, um, it moved this count function in the right vertical line here, right? Indentation is correct, so that's good. Um, but I need to change the variable. It's not location. Here it's body part, right? Body part. The same here, body part. And let's do this again for the third table. Again, this time it's diagnosis. Right. Okay. So now run app. So we expect to see Um, Only 5 rows each table. Very good. Only 5 tables, right? So 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Um, 2, 3, 4, 5, 6. Okay. So we got 6 rows instead of 5 because it's displaying 5 top categories, um, and then all the other categories into this one bucket, other. So top 5 plus other. So that's why it's displaying 6. All right. Uh, okay. So we accomplished the limiting number of rows to top 5 categories, right? The thing is the well, they're sorted as well, right? They're all correctly sorted from the largest value to the smallest in descending order. Okay. Yeah. So the author also used this factor. What's the function? He reordered the levels. He added one more function, but it doesn't seem necessary. Yeah. So factor in frequency. So this function reorders levels in terms of frequency of each category. So you can bring up the documentation and study that. But even without that function, it does it by default, the factor lump function. So that adding that function, it doesn't seem necessary here. Okay. Um, the other thing that you note is the decimal points here. It's probably not necessary, right? So the author has this one more line of code: convert the number to integer for simplicity. So integer n, and we need this code for all 3 tables. Okay, so all 3 tables: diag, body part, and then location. So reload that. There you go. So the decimal numbers are gone, decimal points, right? So they're all integers. So it's easier to read, right? Okay. And the other thing is, so the next thing we can do is to work on the width of the tables, right? We want them to be consistent. So for example, right here, the gap here between the second table and third table is a lot wider than the gap between the first table and the second table here, right? So what we can do here is we can add this to render table function. So width 100%. So it forces the table to take the maximum space. Remember, each table here is given what? So remember, we have a grid here on the screen. It's 12, right? 12 columns in this grid. So each table is supposed to take 4 columns. Remember here, column 4, columns, 4 columns, 4 columns for each table here, right? So making it take up the maximum possible space, right? With this makes the width of each table equal. So let's try this again. Oops. All right. What did I do wrong? Oh, I put it in the wrong place. So I put this. Sorry about that. You should have gone to the render table function. So Control Z to undo. Control Z. Um, this one here is correct in the render table function. So render table. Yeah, here's another render table function, and then run app. There you go. Look at the gap between each table. They're the same. Right? Very good. Very good. All right. So we accomplished our goal, right? However, what you can see in your code, look at the code here. The same code keeps repeating this render table function for each of the three tables. The same code repeats three times, like mutate and then factor lump, right? And then count and then mutate again to convert the number to integers, right? That thing keeps happening, keeps reappearing, right? So in order to reduce redundancy, we can summarize this in a function, and that's what the author did. All right, guys. So uh, So the code the author uses here is slightly different than what we did in our studio here. So we use mutate count and mutate because that count function is what we use in the previous section on prototype. Um, the author, instead of count function, the author used group by and summarize, which is basically the same thing. Okay. So if you look at, yeah, so group by and summarize, right, in the function. So if you look at the result, so select product. Select knives for the product, right? And compare the values in tables. So for dialogue, the largest category is laceration and 287,925, right? So here under diagnosis laceration 287,925, and body part, largest category finger, and then 212, 292. Body part, finger, 212, 292. So it's the same thing. It's the same code. I don't know. He decided to use group by and summarize instead of count function that he had in the previous sections. Either way, either way is fine, guys. Okay. While looking at or comparing the table here, what I realized is this other category is all at the bottom in the textbook example, right? Whereas our case is it's strictly by the value in the end column, right? So as a result, other could be in it could be any place. Whereas here in textbook example, other is at the bottom, right? So I believe that is a reason why the author included this factor in frequency function. So let's try that. Because remember, guys, this other category is not a true category, right? Um, all the rare categories outside top five are thrown into this one huge bucket other, right? So it makes sense to put other at the bottom, okay? So let's do that here. So yeah, factor in frequency. So you can see that documentation here. Reorder factor levels by forced appearance, frequency, or numeric order. So there are three different variations of this reordering levels function. So there's a factor in order, factor in frequency, factor in sequence. So in this case, factor in frequency by reorder levels by number of observations with each level, largest first, right? So do that. The same here. Oh, where's the other table? Oh, right here. Factor in frequency. Reload app. Oh, you're not at the bottom. So maybe we close the app, run fresh. Hmm. All right, that didn't do it. All right, guys. So it turns out the reason that we found consistency in the placement of this other category in our app is this the sort argument in the count function. Okay, so factor in frequency. Um, sets the order of levels, right? But then it's overwritten in the next line in the count function with a sort argument, and therefore other is not at the bottom. Okay, so a solution here is to remove this sort argument, and so that we can retain the order of levels set by this factor infrequency uh, function, right? So so we just deleted sort argument in a table. There's a second, and here's third, right? And let's reload. There you go. Others at the bottom, and looks like all the tables are descending order. All right, very good. Um, okay. Now the last thing we want to address is the redundancy. Um, you know, you can see that this code here keeps repeating each of the three tables. So a function is a great way to reduce the redundancy in the code. So let's write a function here to display top rows. So author named the function count top, and inside the curly bracket goes this uh, body of the function. Uh, so from here to there, okay? And then inside parentheses, we need to define what varies. So the most important thing here is the variable. So the location in the first table, uh, body part in the second table, and diagnosis in the third table, right? So the location, so double curly bracket and space and argument name. Okay, so argument name, we have variable. So this variable is actually or refers to a column in the table. Okay, the same here, location, double curly bracket, space, and variable. The same thing here, double curly bracket, variable. Okay, and then um, um, the author um, made two other things a variable, but it's not absolutely necessary in our case. But to be consistent with the textbook example, uh, let's make this number of top rows to display. So the example that we've been working with, we use 5, but let's make that number of, say, rows, okay? So that that varies, right? We can make that variable, right? We can also make the data a variable, which is a case when you want the function to use for different data sets, okay? Not just a specific data set, which is not the case this time, but the author made it variable. So just to be consistent, you can name it anything you want, dot data, or you can use df as the example in the textbook, right? So let's run this so that we have the, let's close the app so that we can uh, run this code. Oh, right, right. So instead of equal sign, we need colon and equal sign. Um, so I believe this is because, you know, uh, the variable that we're creating is the variable in the function. Okay, so let's run this. Control Enter. There you go. So in the environment, we have this count top function show up. So now we can use this function to reduce code here. So count top, right? Hit tab. So that data is already taken care of. And then variable n rows, right? So the variable, the first one was location, and we can specify dot rows and type 5. However, uh, I mean, we're going to use 5 uh, and we're not going to change this. And so the typing that is rather hassle. So in that case, we can provide a default value 5. So so that if we don't specify it, R would assume that it is 5. Okay. So the others, the same. The second table is count top, the tab, variable, and what was it? Body part, right? And the third table, count top, hit tab, variable, diag, right? And so you see how it's a lot more concise and readable with the function. And one app, there you go, right? Okay, so we're done with improving tables. In the next video, we are going to make this plot. Um, we're going to make it interactive so that the user has option to go back and forth between uh, the rate of injuries per 10,000 people, this plot, right, and count of injuries. So yeah, so the app will have two options, options for two plots. Okay, not just one. All right, great job, guys. I'll see you in the next video.